This, dang it, I forgot my book over there. All right, guys, hold up. Okay, so this was the sheet that I added late last week, and this was one thing we had to deal with, right? Um, I was hoping to break down and see that, for instance, one standard deviation is 66%. So from the mean to the left is 34, to the right is 34, right? We can break up these parts, and then we're able to combine them if we have information that we're trying to find it between this standard deviation and this standard deviation. So that's what I kind of wanted to demonstrate here with the Play-Doh, because if we look at this, just break these in half. Well, break them in half. Oh man, see, this is where I would have went and bought like 40 things of Play-Doh, and we would have done this in class. But we can still do it here. Okay, so that line's kind of messed up. That's all right. So if we look at this, we know that one standard deviation like this, one standard deviation is basically looking at this and saying, well, if here's my mu, here's negative one standard deviation, here's one standard deviation, right? And because I know that all of this, right, is 68%, watch what we're going to be able to do. We can separate the middle parts, and we could say, oh, yeah, you know what? This side over here is 34, and this side over here is 34. Oh, man, you can tell I haven't played in Play-Doh very much lately. All right, you can see that as 34, maybe. All right, we'll try it. Okay, so that's 34 and that's 34. The reason I wanted to do this is, say if we need to find the percentage that is between negative one standard deviation and 2 positive standard deviation. So we want to find all this. Okay. Now I can't just look and see, well, it's going to be 68%. 68% would be between negative 1 and positive 1 standard deviations. But what I can do here is I can go and say, well, let's go ahead and make one that is 2 standard deviations. Let's do that in red. So I cut up the red. Oh, man. I cut up the red like this. And let's say this is mu. Here's negative 1 standard deviation. Here's standard deviation. Here's 2 standard deviation. Here's negative 2 standard deviation. Easy for me to say. All right. We know that's 95%. So in the chat box, go ahead and tell me, what is each of these going to be equal to as far as a percentage goes if I know that 2 standard deviations, so going 2 in each direction, gives us 95%. What is that and that going to be? Nice, Isabel. Perfect. All right, and it looks like it's going to be kind of hard. I'm just gonna write this 34%. Hard to see in the red, I'm sure, so I'll just put them here. Up here we have the problem we were just looking at. We have 47.5%. Here, same, because I cut in half. Right? Good so far? Okay, so here's the thing. Good, Alicia, perfect. So if I look at this and I'm saying, well, look, I need to know what percentage is going to be from the mean, negative 1 standard deviation. Look what I could do. I could take this guy. I could say, well, that's going to be that side, 34%. Now, what else did I need to do? I needed to go from mu over to the right 2 standard deviation. You see how it's different? We're not going to take it from the yellow. We're going to take it from the red. We're going to take this one because that's from mu to the right 2 standard deviations. So I look at that and I take this guy, I put it here, and then we just have to remember, we got to look, is this representing what we have up here? Yeah, now we have it, right? And because I had labeled it before, I knew that this was 47.5. I knew that this is 34. So all I have to do to figure out what percent is between between negative standard deviation 1 and positive standard deviation 2. I just have to add those together. And 47.5. 11, 1, 8. All right. So we'll say that, yeah, from negative standard deviation to 2 standard deviation is 81.5%. That is actually the biggest part of what we were working on. Okay. Give me a thumbs up, sideways, down if seeing it kind of like in pieces was helpful. Okay. I won't go to the Dollar Tree if not. All right. Seems like it's mostly good. Okay. So let me put these pieces back, and then I want to at least go through a couple of homework problems. So if you had any homework problems, I'm going to do this one like this. Right. If I just use half, then I know that's 50%, and that's 50%. If it was cut perfect, right? Oh man, this is good. All right. I'm starting my own Khan Academy. It's Play-Doh Academy. All right. Any homework problems you want to look over? What do you say? Nothing? Somebody in the chat. I want something to do. This is the third look at it though, so maybe we are solid with this. No? All right, well, we only have 10 minutes, so I'll just wait here. I'll just wait here patiently for 10 minutes. Wait, I have something. I have something. That took a long time. Oh, no. Shoot, I had my microphone away from me. Could you guys hear me? Dang it. I hope so. Okay. This is all I was going to get. I have little sound effects. So, when no one speaks up. Question number 4. Look, see, the crickets inspired you. Yes, you can turn in the homework up till 11:59 tonight. So just wait till 11:55. Knock it out. All right, so we're going to do number 4. I'm just going to knock it out from the workbook because I have the workbook here and it's ready to go. All right. Unless it was the book. Rosselli, which one did you want? If it don't matter, it don't matter. All right, here we go. Number 4. Okay. So number 4 here. Let's see. We're using this information for down there. So let's see. Oh, this is about the cases? Right. Cell phone cases. All right. Wait. We're still on 111, aren't we? Yeah, we stayed on the lesson. Sorry. That's right. I was like, I have to teach you more than I thought. No, we haven't done that part yet. Let's look at this. I'm going to squash my Play-Doh. All right, looking down here, we have what? Let's see, we're using this information. So the response time for a certain ambulance company, right, are normally distributed with a mean of 12.5. So I'm going to go 12.5. I know that's my mu. Remember, mu is our mean. They're the same, and that's how we pronounce it. Okay. So let's see. 95%. Remember the empirical rule. That tells me something. 95% are between 10 and 15 minutes. Okay. Let's see. What percent of response times are longer than 15 minutes? This is perfect because we use Play-Doh. So number 4 is saying what percent is greater than 15 minutes? Just leave it like that. No. Okay. That happened. That's okay. Check it out. Play-Doh is resilient, just like us. Can handle that little side note. Unless my dog eats some Play-Doh. Is Play-Doh bad for animals? Yeah? Roselli
I
knows.
think yes.
Oh no! Did she eat it? She didn't eat it. But where did the other green half go? Wait, did you eat it, dog? Okay, guys, this happens. And I hope it... Oh, there it is. Whew. My dog lives another day. All right, here we go. So we're looking at this problem right here. And we're trying to figure out, okay, well, if we have 95%, 95% sure looks like this. 2 standard deviations in each direction, right? So 95% looks like our red our red normal curve here. Okay. So looking at that, we want to find the percent that are greater than 15, right? So look, if we're told that this is 10 minutes. Actually, we weren't told. This is 15 minutes. How do I know? How do I know that that's approximately where they're going to be? Because of this hint that's 95%, okay? Within the context of the problem, that's definitely showing that. All right, Isabel, have a good one. Perfect. Between 10 and 15 is 95%. So because we're studying standard deviation, we're going to assume, yeah, we're talking about this 2 standard deviations from 10 to 15. And I also look at that. Would that put mu in the middle? 12.5. Yeah, 12.5 is right between 10 and 15. So I know that's how it's going to work out. This is 12.5 in the middle. All right. So now looking at that, we want to find the percent that's greater than 15. So that means we're looking for this. What percent is just this little sliver right here? Okay. So we got to think about that. Here is exact example of how we can do this effectively. Now watch. I'm going to take this piece out because I know that piece equals 50%. Right? Now we have on this side, this entire green half here is 50%. Does that make sense? See how I just chopped away? I just took the green, put it right there. So since that is 50%, and we know that it went, let's see. We know essentially what we're trying to figure out is how much this slice is, okay? So what I'm trying to do is, okay, let's figure out what all the rest is and just subtract it from 100. Everything under the curve is always 100. So watch. We know this is 50. We know that's 47, so I'm going to add those together. 47.5. 579. So I know that all of this red and green over here is 97.5. 97.5. Okay? So if that's 97.5, what is this little sliver on this side? Let's see. Right? $2.5. This little bit over here is 2.5. The other bit you could have done the other way to do it. So there's all a bunch of ways to break this stuff up. And maybe you're like, Mr. Pacivas, why didn't you do it this other way? Let's see. All right, we know the middle part was 95. So I take away the middle part of 95. These two here must add up together to be 5 additional percent. If the middle part here, right, was 95%, then the other two have to add up to 5%. And then what's half? What's half of 5%? 2.5. Okay? Thumbs up, sideways, down. You seeing it? Thumbs up, sideways, down. Okay, that's all thumbs. Nice. All right. It looks like right now we have another 5 minutes. So we can do one more problem. Anyone else have a problem we should look over? It's a freebie. Get a free problem done. All right, just waiting in the chat. I can also just do a problem. Okay. We could do this. can do this. Okay, the next thing I'm going to do is set you up. Stephanie, clarify that chat. I didn't quite understand.
Like just choose a problem, like a random problem.
Oh, I see. That would be easy. Okay, perfect. Yeah. Good. So I think you guys, we've gone over a lot of problems, so I'll just do one. Good suggestion. And let's say this. Let's say that on the SAT, right? SAT, you scored let's go 600 on English. Okay? 600 on English. And that 600 on English equates to scoring better than what percent of students? Okay, so let's also put that our mu is, okay, let's just make it, it's not perfect. Our mu is going to be 500, right? And our SD, our standard deviation, we're going to say is 100. Okay. So right off the bat, you know that this is going to have us set up to do normal curve. So I would just start by drawing it all in. 500 is our mu. Okay. SD is 100. So I'm going to look and just put 100. Remember, standard deviation is always from mu. Yeah, I can't see that. And if I have a standard deviation of 100, I know that I'm going to go over 100, and I'll be here at 600 for my 1 standard deviation. I'll be here at 400 for my -1 standard deviation. And that might be all we need to figure out, right? Because what do we just find out? What do we just find out? We know where we fit as far as English goes. 600 is going to be 1 standard deviation over. Now let's look at what it's saying. And this is a good intro to what we'll hit tomorrow, okay? Because look, 600 equates to scoring better than what percent of students? So watch what we're doing. We're going to find what percent fits to the left. You scored better than all those students, right? You scored better than all those students. That's what it would mean. So I look here, and essentially what I'm trying to figure out is, from these, I'm trying to figure out what percentage is in that green kind of, the green or orange. That's neither green nor orange. The yellow, normal curve right there cut up, right? Okay. So let's see. I want you to strategize for a second. What pieces up here should I pull down to try to figure out how much all this is? Because right off the bat, I don't have this information, but there's a real simple way. We can do this with 2 pieces from our pieces up here. So which 2 pieces should I do? In the chat, go ahead and tell me the 2 colors that I'll use in order to find out, well, how much is less, what percentage is less than 1 standard deviation? Because that's our problem. Okay, so tell me in the chat what colors am I going to use for this? We got red, we got green, we got yellow. Nice. Alicia, perfect. Perfect. All right. Soraya, we will use the green. We have to use one other color, though. Good, Travis, you got it? Roseli, perfect. Perfect. You're starting to see it now. Anybody else want to chime in? Okay. Well, we're just going to end class soon, so I'll go ahead and do this. We are going to keep this yellow one here because I know it's from here over, and that gives me a good amount from there to mu, right? I'm going to move these yellows out of the way on this side and do what? Take the half green, put it right there, right? Now it's easier for me to see. Oh, okay. Now it's easier for me to see that this side over here is going to be 50%. 50%, half of the 100. This side here is going to be 34%. So the answer to our question is you scored better than, we add these together, 84% of students. Better than 84% of students, which is pretty good. Okay. That's actually about what I wanted to go over, and it's the end of class. So give me a thumbs up, sideways, down. Does that help? You guys feel better about it? In the sideways, still shaky. Okay. You'll be able to at least review this video and go over this again. We didn't get through any homework problems really, other than the first one we did, question 4. Okay. 16. 16? 16. Not sure what that means. Okay. Anyways, I'll try to do other things like this.
I didn't mean to clip that. My bad.
Okay, all good. I thought it was like some kind of like riddle for me. It's like 16. No. Okay. All right. Okay, you guys are good to go. You guys are dismissed. I hope that helped. I'll see you tomorrow afternoon. Keep you guys' head up. I know this is hard work, and you guys are getting a lot of homework right now. I changed the timing of the homework, so stay after if you need help with that. Otherwise, I will see you tomorrow. Okay, guys?
Thank you, Mr. Pacier.
All right. Thank you.
Bye.
Take care, guys. All right. Stick around if you have more questions.